All right, so we are going to do quadratic functions. We're going to be factoring them, okay? The first 5 questions are going to have no number here in the A section, which will make sense a little bit later, but for right now, there'll be no numbers here in the front, which makes these very simple. I've left a very small amount of space. So these are the result of 2 binomials multiplying, okay? We're trying to figure out what numbers multiply to make 20, but when you add them, they make 9, positive 9, okay? So let me see, it's going to be, okay, first ones are going to be x and x, because then x and x are going to make the x squared, right? Then we're looking for 2 numbers that multiply to make this, and when you add them together, they make 9. So we're thinking 4 and 5, positive 4 and positive 5, and that is factored. Okay, so these have been factored. That's it. Okay, if you multiply this, if you do the distributive property twice, your end result will be this. Okay, so this number is important, and this number is very important as well. You have to think of 2 numbers that multiply to make 20. So it could have been 20 and 1, but it wasn't because they have to add to make 9. So 4 and 5. And both of them are going to be positive. Okay, so let's look at the next one here. So this one says x squared minus 8x plus 12. So we're looking for 2 numbers that multiply to make 12, but when you add them, they make 8. Okay, so for this one, again, we know that we're starting with the letter in the front on both, x and x. Now we've probably figured it out. It's 6 and 2, but it's not going to be positive and positive. It's going to be negative and negative. That create negative 6 minus 2 will create the negative 8, and negative 6 times negative 2 will create the positive 12. This sign is like a hint. It tells you, hey, both of these signs are going to be the same, okay? And in your head, when you're thinking of the numbers, you should be thinking adding. 6 and 2 should make 8, okay? This is always going to be the sign of the number that's the largest. So if they're both the same and the largest number is going to be negative, that means they're both going to be negative. All right, so let's go here. So here we're thinking of 2 numbers that multiply to make 15, but when you subtract them, they make a 2. Okay, so you're thinking 3 times 5, right? That makes sense to me. When you subtract them, they do make a 2. And the largest of the 2 numbers, which is the 5, is going to share the same as that one. So it's going to be plus. So that means this one's got to be minus, because they're going to be different. How do I know they're going to be different? This one here is a minus, which means it's going to be different. So let's do this one now. And we'll talk about the signs before we even start. So we know that this is going to be x, and we know that this is going to be x, right? We know that the signs are different, and that the largest one is going to be negative. You see? Immediately I know that. So 2 numbers that multiply to make 18, but when you subtract them, they make a 7. Okay, or a negative 7 in this. So we're going to be saying 9 and 2, right? 9 and 2. And the largest number is a 9, and it shares the minus sign. And we know the signs are different, so there's going to be a plus. If you ever are worried about something, just do the distributive property and multiply these binomials. And if your end result is not the same as the top, then maybe you made a silly mistake. All right, last one here, trying to trick you here. So this and this equals 27. Now, this doesn't look very similar to what we've been seeing here, so I'm going to move this 27 to the other side, leaving the sign empty. So it's going to leave you with x squared plus 6x minus 27, and then this is now 0 because there's nothing over here. I subtracted 27 from this side and subtracted 27 from this side, and there it is. Now I can do it the same. I can factor these the same way I'm factoring this. I'm looking for the results that will give me 0. All right, let's see. So what 2 numbers multiply to make 27, but when you subtract them, they make a 6? Well, it could be 9 and 3, right? So x, 9, and 3. You should be thinking, where does the sign go? It goes right here. And this is the other one. And this equals 0. So how can I make this equal 0? Well, when this equals 0, 0 times anything is going to make 0. So all I have to do is think, I'm going to make this 0. So x plus 9 equals 0 when x is negative 9. So that's one of my solutions. But also, if I make this 0, it doesn't matter what this is, it will equal 0. So another answer could be from making this 0. So x minus 3 equals 0. So if you add 3 to both sides, x equals 3. Here are my two solutions for this problem. All right? Now, let's go here. Now, there is going to be a number in the A section. So there's going to be a number there. So the way that you do this is you multiply the first number and the last number. That's going to give you some number that you're going to put up here on the side. That's going to be 28. Now, this is the number that I'm going to say, what two numbers multiply to make 28, but when you put them together, they make 29. So that's pretty simple. 28x plus 1x. That will make the 29. Now, in this one has 3 steps. The first step is to figure this out, what you just did. Add 4, that just comes down. The 7x squared just comes down. So that's the first step, okay? Figuring out how to split the center. Once you've split the center, you're going to separate the front from the back, okay? You're going to factor out something here, so meaning divide out. Okay, so we're going to factor out something that these two have in common. They have a 7 in common, and they also have an x in common. So if I divide it from here and divide it from here, because I've divided it out, it's going to leave me with an x here and a 4 here. Okay, so x plus 4. Now here, there's nothing I can really take out. They don't have an x in common. They don't have a number in common. But I do have to take something out. So what I'm going to take out is something. My eraser is falling. I'm going to take out something that is divisible into both. These are both divisible by 1. So I'm going to take out a positive 1 because I have to remove something from it. I'm left with an x and a 4. So nothing has changed. Because I have to remove something, I remove the plus 1. Now, that is the second step. So going from here to here is the first step. Going from here to here is the second step. The third step is you write down what is not in parentheses. So that would be the 7x and the plus 1. So you write what's not in the parentheses in parentheses. So 7x plus 1, that's going to be in parentheses. And then the other one, okay, is going to be the x plus 4. You see how these are both the same? If you make these both the same, then you have done a good job. You've done it correctly, okay? So now I'm going to put that here, x plus 4. And that's it. So you write down what's not in the parentheses, and then you write what's in both of the parentheses, which is x plus 4. And that's your end result. If I were to do this, okay, and then do this, that's really the same thing as doing this right here, because 7x is going to multiply with both, and then the 1 is going to multiply with both. So it's really doing the same thing. A lot of people wonder, why is there not another one? Okay? I just explained why. So let's do this one. Let's make a little line so you can separate these. So now we're doing this one. So we're doing 3 times 20. Okay, so 3 and 20, this is step 1. We're going to be left with 60. So 60, what two numbers multiply to make 60, but when you add them, they make a negative 17. So it's going to be 20 and 3, right? So it's going to be negative 20x and 3x plus 20 and 3x squared, right? So now that I've done this, I get to separate them. So 60, so now that was step 1. So now we're going to do here, and we're going to do here, right? So this, the only thing they have in common is x, so I'm going to take out an x. That's going to be 3x minus 20. Then on this side, I'm going to also take out, well, I can't take out anything, so again, I'm just removing a 1, so I'm going to take out a plus 1. And it's going to leave me with 3x, all right, plus 20. Stay the same. Now we have an issue here. Look, this is 3x plus 20, and this is 3x minus 20. Right? So there might have been an error here. I have a positive 60. These are both supposed to be the same. It looks like I made a mistake somewhere. It's going to be, it's not 20 because they're adding. See? I've made a mistake. How did I figure that mistake out? This and this were different, and there was no way to fix it. So now I go and I notice that both signs have to be the same. So now I'm looking for something that makes 60. So it's going to be 12 times 5. So negative 12x and negative 5x with the plus 20 over here and the 3x squared. Man, that was, there we go, the perfect example of what this does when you make a silly mistake. So now that I've corrected it, it's negative 12 and negative 5 to make this. I will go back to step 2 and separate what they have in common. Now they have 3x in common, which will leave me with x and a minus 4. And here I'll take out negative 5, so I'll take out a negative 5. And now I'll leave me with a positive x and a negative 4. Look at that, I've done it correctly. So now the end result is what's not in the parentheses, so 3x minus 5, and what is in the parentheses, which is x minus 4. I went through a lot of work to make that mistake. Look at that. Okay, so that is done. That is factored. Okay, now we're going to be factoring squares. So here we go. This is going to be factored, and there's something missing in the center. I know this can be factored because these are perfect squares, and there's a minus sign in between. Okay, so that means that it's going to become, now it's missing the number in the center, so I know that one is plus and one is minus. Okay, so this is going to be the result. I have to just square root the front and square root this, and our results should go here. So what times itself makes 16h squared? It's going to be 4h. 4h also goes here. And then what number times itself will make 9a squared? It will be 3a. 3a. So now we're going to be going over here doing the same exact thing. What times itself? So again, this is a perfect square. That's a perfect square. So I know that I'm going to have a plus and a minus, and there's a minus in there. And the minus sign in there. So now that should do it. I'm just going to change this to 11. Change it to 11. This is going to be what number times itself makes 4b squared. It's going to be 2b and 2b. You can check my work. Your result will be this at the end. Here we go. That's not a perfect square, and that's not a perfect square. Okay? So if that occurs, before you write prime immediately, you have to check if you can take something out of these. So these are both divisible by 3, and they share a g, so I'm going to take out 3g and see if that fixes this issue. That leaves me with 9g squared minus 1. Well, now that's a perfect square, and that's a perfect square, and there's a minus sign in between. Perfect. So now I'm going to factor this. So 3g is still on the outside, and now we are left with 3g plus 1 and 3g minus 1. And that should create this. What times itself makes 9g squared? 3g. What times itself makes 1? A 1. All right, let's get rid of this. Scroll down here. Okay, so now we have b to the 4th minus 16. Okay, that's a perfect square because I can do b squared times b squared. And this is a perfect square because it's 4 times 4. So I can split this, and I'm going to get b to the 2nd power plus 4 and b to the 2nd power minus 4. Uh-oh. This one can still be factored. It has a perfect square, and it has a minus sign between. This cannot be factored. It has a plus sign. So plus 4. This is going to factor into b plus 2, b minus 2. So this one here has been factored. All right. One more over here. This is the result of 25 times 25, so it is a perfect square. And this is also a perfect square because x to the 4th can be split from x to the 2 times x to the 2. So I get this. Now this is done, but this again can be split a little bit more. So this stays here. This splits into 5 plus x and 5 minus x. And then we are done with that one. So this is the factored result. Now we're going to be doing this one, and then we're going to solve for 0 at the end. So again, these are not perfect squares, so I'm going to at least try to factor something out before I say it's a prime. So they're both divisible by 5, and they both share an x, so I'm going to take a 5x out. That'll leave me with x3, and this will leave me with 9x. Okay, equals 0. Oh, 9, just 9. Okay, just 9. So, when does this equal 0? When this equals 0 and when that equals 0. Okay? So, I made this one up and now I'm regretting it. Okay, so, I know that if this is 0 times this, it'll make 0. So I know x can be 0, right? 0 times 5. 0 times 5 is going to make 0. 0 times this will make 0. So x equals 0. So when does this equal 0? So I'm going to add 9 to both sides. X to the third equals positive 9. Cube root. So x equals the cube root of 9. So the cube root of 9. None of the answers are going to look like that, but I started one. I had to finish it, guys. So that's one of the answers, and that's the other answer. And that's it. Good luck.